Well, hello geometers and seekers of truth. In this video, I am going to demonstrate to you proposition 118, which states that in any triangle, the angle opposite the greater side is greater than the angle opposite the smaller side. And before we get into this too far, what we should try and do is rewrite this statement here. We'll use this picture here as our example to work with, right? So we want to write it as a conditional statement. So in triangle ABC, if angle ABC, if AC, line segment AC, is greater than AB, okay? So let's say that AC is the longer length, and compared to AB, this is the smaller length. Then what this statement is saying, the angle opposite the greater side, so the angle opposite of the red line is this angle here, okay? Then angle ABC is greater than the angle opposite of side length AB. Okay, so in other words, the red side is longer than the blue side, so the red angle must be larger than the blue angle. Okay, so that is what we're trying to show in this proposition. Okay, so angle ABC would be greater than angle ACB. Okay. All right, I've erased all the marks here because I'm going to use it to demonstrate, use the picture to work with my proof, but hopefully the highlighting there helps you to identify what we're doing here. So let's get started with the proof. So we always start with the assumption, let AC be greater than AB. Okay. Well, now if that's the case, well, what does that mean? Well, that means something that I can do is that I can take a point here on AC that's equal to AB, right? So if AC is longer than AB, then I can cut off some part of AC and have the remaining parts equal to AB, okay? So place D on AC such that AD is congruent to AB. Okay, just like that. Now, before I go too much further with the writing, I think it's always helpful to visualize. Let's call this point here is D. DAB is an isosceles triangle, so these base angles here, they have to be equal to each other. These two red arcs here, they have to be equal to each other. Okay. And then what is also very helpful to compare here, and I'll highlight this with some pictures here, are three angles. There's the blue one, there is this red one right here, and then let me add another color here, the green one. Okay. And as you're watching this video, to get the most out of this, to most understanding out of this, ask yourselves how would you rank these three angles in order? Which one is smaller, the blue one or the red one? Which one is smaller, the green one or the red one? Okay, and from there we'll be able to complete this proof. Okay, so I'm going to make a claim to you. I'm going to say that this red angle right here is larger than this blue angle right here. And the reason I can justify that is that the red angle is the exterior angle of this triangle BDC. Okay? So I'll write this up. Angle ADB is greater than angle ACB. That's the blue one. Okay? So this red one right here is greater than this blue one here. And this is because of the previous proposition that we proved, proposition 116, the exterior angles theorem. And I'll write my reasoning in here. Because ADB is an exterior angle of triangle BDC. Okay. Now, if you notice though, let's look at the other part of this, okay? The green angle is clearly larger than the red angle. So we'll write down here. Angle ABC is greater than angle ABD. Okay. And this is common notion 5. The whole is always greater than the part. Okay, so the green angle is greater than the part. Okay. Now let's look at one more statement. Angle ABD must be congruent to angle ADB. And because they're base angles, or this is proposition 7, I think. Okay, we gave it a name, the base angles theorem. Okay. And from these last 3 sentences, we have enough to complete our proof, and I'll show it to you. I'll do it visually first before we write it down. The green angle is bigger than the red angle, but this red angle is equal to this red angle, which is greater than the blue angle. Therefore, the green angle must be greater than the blue angle. Okay, so another even shorter way to say it, green is greater than red, red is greater than blue, so green is greater than blue. So we have to join that together in a few little pieces. Okay, so let's start here. ABC is greater than ABD, and ABD is congruent to ADB. So let's see. Let me if I can. Oops. Okay. So I'll use mathematical symbols. ABC, that's from step 3, is greater than ADB. ABD, I'm sorry. Okay, that's this red one here. But that one is congruent to ADB, which is this red one right here. But this red one is greater than the blue one, which is what we have here in step 2. Okay. So if you kind of take away the middle part here, we can conclude what we're saying is that ABC is greater than ACB. This last statement here, we can come to that using common notion 1. Things which are equal to each other, the same thing, are equal to each other, and things which are equal to different things are not equal to each other. In modern terms, we have a bunch of special names for this, the transitive property of inequality and substitution, and the transitive property of equality. But it's sufficient here doing Euclid's proof to appeal to these common notions. All right, so there we have it. What we know from this information is that in a triangle, whatever angle is across from a larger side is also the larger angle. Thank you for watching. Have a wonderful day.